Trigonometry special angles. This involves all multiples of 90 degrees, multiples of 30 degrees, and multiples of 45 degrees. We can find them without using a calculator. Let's start with the multiples of 90. At 0 degrees, we have r lying along the x-axis, the coordinate to the end point r 0, and we can slot into the trig ratio. 90 degrees, we now have 0r, and we can put into the trig ratios. Note, tan of 90 undefined, you cannot divide by 0. Now, because it's on the left, we'll have negative r for the y value, so it's 0 negative r, put into the trig ratios, and there we are. 270 degrees, 0 negative r, so y is now negative r, put into the trig ratios. Once again, you cannot divide by 0 in order to find tan of 270. And as it says, now that you've seen the reasons, let's get real. Nobody is going to know when you're finding a trig ratio of any of these multiples of 90 if you use a calculator. So use a calculator. But don't tell anybody I said so. 60 degrees. Let's draw an equilateral triangle. Means we have 60 degrees all the way around. Let's just look at one of them. Let's let the sides be 2 units long. We can let them be any units long we like, because trigonometry involves ratios, not actual lengths. 2's all the way around. Why I had 2's? Because I'm going to drop a perpendicular. Notice, because it's 90, 60, that has to be 30. And the reason why it's 2 I chose, because now the perpendicular bisects the base and we end up with a 1. Without any pesky fractions. The length of that, alpha, let's work it out using Pythagoras theorem. There we are, Pythagoras theorem. Alpha is the square root of 3, so let's replace that, square root of 3. So now we have a right angle triangle, and from there we can find all the trig ratios. Sine 30, y over r. There's the y for 30 degrees, the x for 30 degrees, adjacent to the 30, opposite the 30. R is always r. Cos 30, tan 30. Notice that 1 over root 3 can be written as root 3 over 3. If we multiply top and bottom by root 3, multiply by root 3 over root 3, because that rationalizes the denominator. I mention it because that's the way the calculator will give it to you. 60 degrees, so now that's the y for 60 degrees, the x for 60 degrees. Put into your formulae, into your definitions, and there we are. We have the trig ratios for 60 degrees. Note, cos 30, sine 60, the same result, sine 30, cos 60. Why? Well, the only difference between these names is a cosine, sine. They are co-ratios. Remember, complementary, meaning adding up to 90 degrees. So cos of 10 would equal sine of 80, cos of 20, sine of 70. So cos of 30 equals sine of 60. That's quite useful, because that means if you want to memorize the special angles, you can memorize just the sines. 30, 45, 60, and you'll be able to get the coses immediately. Let's look at 45. Right-angled isosceles triangle. Right-angled isosceles, because then that gives us equal angles, adding up to 90, making them 45. I'm going to let the sides be 1 unit. I'm not going to divide any, so let's not complicate. By Pythagoras theorem, I can find out that alpha is the square root of 2, so now we have the lengths of the 3 sides. Slot into our formulae, sine y over r, cos x over r, tan y over x. And here I have the trigonometric ratios for 45 degrees. Notice once again, 1 over root 2 goes to root 2 over 2. Rationalized denominator, because the calculator will give you that answer, not that answer. Useful way to work out the special angles, that's often taught by some teachers. Have a look. I've got 0, 30, 45, 60, 90. Label the x's from square root of 0 to square root of 4. Easy to remember because the x's are 0 there and at the longest there. The y's 0 there and at the longest there. Going the other way. All the r's are the square root of 4. 2. Now we just slot into our formulae, and that gives us all our possibilities. Useful thing is if we want sine of 45, it'll give us root 2 over 2, which is what the calculator will. That's sometimes put into a table, like this, where we start at root 4, we start at root 0, and these are all root 4s. And in the same way, we can slot into trig ratios. Of course, aren't calculators useful in no calculator questions? Because if you've got to enter sine of 60 into a calculator, it'll give you root 3 over 2. So who knows that you didn't use a calculator? But the only thing is, you must show working. Otherwise they'll say you've used your calculator. The important thing is to show an understanding. Let's look at an example. If you're told to find 4 sine 30 cos 45, if you enter that straight on the calculator, it'll give you root 2, but you must show that you said 4 times a half times root 2 over 2. If you use a calculator to get those, that's fine. There's another one, sine squared 270 degrees, so therefore negative 1 all squared, root 3 over 2 all squared, and 1. Square that, 1. When you square root 3 over 2, you square the top, getting 3, square the bottom, you get 4. And if you add those two together, 2 3/4, or 11 over 4. Let's do some examples. Here we are. Sine 60 minus sine 30. So, there we are. With a calculator if you want to. Otherwise you can memorize. It's useful to memorize them. It is. Because sometimes you need to recognize them. There we are. Number 2. 2 over tan 45. Easy. Number 3. Same thing. The values. And then show your final answer. This one here, that's root 3 over 2, and that is a half. So when you're dividing by a fraction, you take the top and you multiply by the inverse. Look, oh, flip. The 2's cancel, we end up with root 3 over 1. 1 minus a half. Root 3 over 2 minus a half times root 3 over 1. Now if you have a look, root 3 over 2 times a half, root 3 over 1 times a half gives you root 3 over 2. That's why we've ended up with 0. Square the value of sine of 60, square the value of cos of 60, ends up with 3/4 1, which is 1. For those who are now in grade 12, you'll remember this. This is actually a trig identity, so you'd go straight to the 1. Numbers simplifies. Numbers simplifies. Notice 2 times root 3 over 2. Sine of 60 is root 3 over 2 all squared times by 1 over root 3, or root 3 over root 3 over 3 will probably be given to you on your calculator. But any way you work out, you'll end up with 4 over 3. Finally, negative 1 root 2 over 2 half plus root 3 over 3 all squared. So this works out eventually to negative root 2 over 4. That stays as 3 over 9, which is 1/3, and you cannot go on anymore. You may have to prove statements. Prove that cos of 60 plus 30 equals cos 60 cos 30 minus sine 60 sine 30. You cannot work with both sides at once. Remember, when you're proving one thing equal to another, you have to take one side alone. So I'm going to say left-hand side equals cos of 90, 60 plus 30, 90, and cos of 90, naught. The right-hand side, half times root 3 over 2 minus root 3 over 2 times a half. Notice I'm showing all working because I've been told to prove it, and that gives you 0 equals left-hand side. Here a whole lot to do. Well, left-hand side, right-hand side, there we are. That over that, which means that multiplied by the flip, and it simplifies to root 3 over 2 equals left-hand side. Left-hand side naught, right-hand side we slot in our values, and they're the same thing, so they become 0. Left-hand side a half. Right-hand side, slot in your values, that becomes 0, so 1 times a half is just half. Root 3 over 2, values in, and it simplifies to root 3 over 2. Half for left. Simplifying right, notice that means cos of 30 all squared, so it's root 3 over 2 all squared. You must show that. You must show the result of root 3 over 2 all squared, and 2 times 3/4, 3 over 2. You must show that working, show that. That becomes 3/4, a quarter equals 1. Left-hand side naught, 1 minus twice, and then we must put sine 45 in brackets all squared. Give you the 1 minus 2 times a half, which is naught. Left-hand side, 1 over sine squared 60, so it's 1 over root 3 over 2, which is 3/4, flipped is 4 over 3. This side here, sine squared 30, sine squared 60, plus 1. I'm now going to have the top multiplied by the flip of the bottom. That cancels down to a third, plus 1, 4 over 3. Left-hand side, getting more complicated now, except these are like terms, luckily, because that's root 3 over 2, and that's 2 times root 3 over 3. Now if you find a common denominator, you'll get 7 root 3 over 6. Square the top, 49, times 3, square the bottom, 36, and that simplifies to 40 over 12. In fact, that'll go more, because 4 goes to both, so it'll become 10 over 3. Notice this we must simplify first, like that one, so half plus minus root 3 over 2. Now there we're going to square out the binomial, square the first. In fact, what I've done there is I've put that as a common denominator, 1 minus root 3 all over 2. So there's the all over 2 squared, and 1 minus root 3 squared is 1. Multiply the 2 together and double. Square the last with a plus is 3. 3 plus 1 is 4. So we'll have 4 minus 2 root 3 over 4. And 2 cancels in, give you 2 minus root 3 over 2. And if we simplify the other side, we're actually going to get 2 minus cos tan of 60 is root 3, so it'll be 2 minus root 3 all over 2. Right, without calculator. So remember, the first thing we're going to do is we're going to reduce these. We're going to reduce these to first quadrant. So therefore, 180 minus, 360 minus, that's just you take a 360 off it, and sine of negative 30, fourth quadrant, where sine is negative. Second quadrant, positive. Fourth quadrant, tan negative, negative tan 45. Cos 60, negative sine 30. Now we substitute in our values for the special angles. Notice the negatives have gone because I have a negative on top, negative below in the multiplication, which gives me root 3 over 2 divided by a quarter, or times 4 over 1, to root 3. And there's my answer. Sine of minus 210. Well, two ways to do it. Add 360, 150. Write as a 180 minus because it's in the second quadrant. Reduce positive because sine is positive in the second quadrant. Answer. Or, now I remind you, even though this is above 90, remember I talked about a nudge earlier, think of what you do with negative theta with a nudge. Negative theta would put you in the fourth quadrant, which sine negative, so therefore it becomes negative sine theta. So sine of negative 210 becomes negative sine of 210. So there we are. Now we say 180 plus 30 to get to the third quadrant. Third quadrant, I'm not saying 180 plus 30 is the same as 30. I'm saying sine of 180 plus 30 has the same x, y, r's as sine of 30, except for the negative. And that gives you a half. Same answer by a different method. Some calculations. Now each of these you can just drop the negative if it's cos, or move the negative. So in other words, this becomes cos 3315. Notice negative tan, sine and tan go to negative from tan of a negative angle, sine of a negative angle. Negative sine 35. Negative tan 330. Negative sine 210. Cos of negative becomes straight cos. Notice cos 240. It ends up being negative, but that's later because of the 240. Now notice here, this hasn't become negative even though it's third quadrant. Because when you're squaring, even though, negative angle, even though the sine of negative 225 is negative sine of 225, there are two of them multiplying, you're squaring it, so it stays positive. And even though that in itself, sine of 225 is negative sine 45, it'll become sine squared 45 because the negative has been squared out. From there to there, I've just subtracted 360. Right, simplify again without a calculator. Oh, this looks the same as before. Oh, hang on. 30, 60, 50 and 40 are not special angles. So I have a problem here, or do I? Why are these both in blue? Do you notice cosine, sine? 50 plus 40 gives you 90. These are exactly the same values. Sine of an angle is the same as cosine of 90 minus the angle. So those actually go, they cancel. Notice I've actually lifted as cos and written that as cos of 50, just to show the working. Times 2 over root 3, because we're dividing by root 3 over 2. Some more exercises of these for you to try yourself. Notice I can go straight from there to there. I've shown that there, but I can actually say, well, sine squared is always going to be plus. So I don't need to write that in. Here's another case. Notice that cos squared 180 plus 30 is negative cos 30 all squared. These are just for you to do. Pause each time, try it yourself, then continue to check your answer. Root 3 over 2 times root 3 over 2 gives you root 3, 3, 2 2's, 4. Notice here I've saved myself some time. This is turning out as sine 30, so why don't we write cos 60 as sine of 30 straight away? Very complex. Notice sine squared 300, sine squared 60. If we had sine of 300, we'd have negative sine 60, but this is being squared. One of these could be worth quite a few marks to you, in fact, so that's why it's useful knowing these. It's important you show the reduction, though. Don't go straight to sine 150 and enter it on your calculator. It'll give you a half, but unfortunately you will lose marks because automatically you'll be assumed you used your calculator if it's told you no calculator. Notice, therefore, I have my reductions. And notice in blue again, those aren't special angles, but have a look, sine 80, cos 10, they add up to 90. They're equal. Same thing here, do all your reductions. This becomes negative sine 50, and that is cos of 40, not special angles, but they add up to 90, and it's sine and cos. So you can cancel them. Same thing here with the sine 20, cos sine 70, cos 20. Cos 110 goes to negative cos 70, sine 200 goes to negative sine 20, and you'll notice once again co-ratios of numbers adding up to 90 degrees. They're equal. And one final case of that is when you reduce sine 310 to sine 50, negative sine 50, cos 140 to negative cos 40, those two are the same. So therefore it cancels, and this ends up giving you just plus 1.